Hello everyone, my name is Arya Gaikwad. My PRN number is 2003006. I'm here to present about the latest development in the Wi-Fi sector, that is Wi-Fi 6. So this is the latest generation of Wi-Fi as we can see. So let's start with the introduction of Wi-Fi 6. In the connected world of today, faster internet is constantly in demand. Wi-Fi 6 is the next generation standard in Wi-Fi technology. Wi-Fi 6 is also known as 802.11ax. Wi-Fi 6 promises faster speed and higher efficiency. Wi-Fi 6 operates over the band of 2.5 GHz to 5 GHz, and it has a maximum achievable speed of 10 Gbps. It is 4 times faster than Wi-Fi 5, and it is highly power efficient than previous generation of Wi-Fi. As we move on to the next, let us see the key features of Wi-Fi 6. So, the first key feature would be hyper-dense environment performance. Promises higher capacity and coverages in public venue. Better power efficiency is the second key feature. Low latency in data delivery is the third key feature. And for higher speed across devices. So, about the first key feature, Wi-Fi 6 promises to operate in highly crowded areas. And let me explain the other key features too, that is battery power efficient, or we can say it is more power efficient than any other Wi-Fi standard, and low latency in data delivery that will result you in quick searches and less ping, and high speed across devices, which can be understand by that term it is super high speed, that would be around 10 Gbps. So moving on, the key technologies in Wi-Fi 6 are OFDMA for increased efficiency and low latency. Access point connect to more devices at once. And the next technology will be 1024 QAM for increased throughput for bandwidth heavy application. This technology is used. And the next technology would be transmit beamforming to enable higher data rate and increase network capacity. The next technology used is MoMeMo that operates across 2.4 GHz and 5 GHz simultaneously to handle large number of devices, one both at the same time in the both the bands. Moving on next, we see the use cases of Wi-Fi 6. It can be used in mobile broadband, transportation, it can be used in enterprise, smart cities, residential complexes, Internet of Things, and for high density deployment it is used, and for retail giants like Amazon and Reliance Retail, for entertainment, smart villages, manufacturing. So overall we can configure and we can conclude from this use cases that Wi-Fi 6 is used or mainly built for heavy usage, that it could operate in highly dense spaces, it has high speeds. Moving on next, we will see the comparison between Wi-Fi 6 and Wi-Fi 5. Wi-Fi 6 helps router communicate with more devices at once and share data with them in same broadcast. So in 2014, when Wi-Fi 5 was released, an average US household had about 5 Wi-Fi devices that would give an average speed of 3 Gbps. And in back in 2019, homes have 9 Wi-Fi devices on an average, theoretically highest speed 10 Gbps. Within several years, that would be around 2025, homes will have 50 Wi-Fi devices on an average. To support this homogeneous growth, we need Wi-Fi 6 as our most demanding tech. Moving on next, we see how to identify Wi-Fi generations. Wi-Fi generation is now identified using numerical sequence matched to PHY advancement in 2.4 GHz and 5 GHz frequency band. If the most advanced technology a device supports, then it shall be identified as this generation. For example, 8.802.11ax would be called Wi-Fi generation 6. 802.11 AC would be denoted as Wi-Fi generation 5 and 802.11N would be generation Wi-Fi 4. So the device that can support Wi-Fi 6 or that are Wi-Fi 6 supported are Netgear Wi-Fi routers, Deep-Link Archer AX11000, and for a small compact mobile devices, Wi-Fi 6 generation support has begun from a very early stage, that is from Samsung Galaxy S10, and the last device that would support is Asus GT-AX11000. Now there are many more infinite devices in the market that now support Wi-Fi 6. These are the few example of them. Moving on, next we see the benefits of Wi-Fi 6. The first benefit would be increased capacity and data rates. With 1024 QAM, Wi-Fi 6 can deliver a 25% increase in capacity of 256 QAM. Second benefit would be simultaneous multi-user support. MU-MIMO technology and OFDMA help reduce congestion by allowing more devices to connect at once. Third, improved power efficiency. Target wake time feature allows device to plan communications with the router in advance, which helps improve battery life. Performance in hyperdense environment. Multiple access points deployed in dense device environment deliver the desired QoS to client with diverse usage policies. Let us now see the deployment scenarios of Wi-Fi 6. So, Wi-Fi 6 would be deployed in public venues, stadiums, and theme parks. Public venues such as airport, convention center, railway, and metro station receive a high footfall every day. So, what would happen if we deploy Wi-Fi 6? It would improve efficiency of spectrum, enable high concurrent usage, handle latency efficiency with rise in voice traffic, supports increased bandwidth requirement. Next, it can be used in industrial IoT. The Wireless Broadband Alliance and Metis Aerospace announced that the world's first Wi-Fi 6 industrial enterprises and IoT trial. The use cases under this alliance include ultra-reliable low-latency communications, multi-stream live video monitoring, augmented reality, real-time energy monitoring. And the next application would be for smart cities. We can use Wi-Fi 6 in smart cities as it would give increased capacity support with close access points, enable wireless backhaul scenarios through high throughput, special, special energy efficiency through frequency reuse feature, congestion planning for smart other networks. So these are some of the references from which all the data has been derived for the slide. Now I here declare the end of my presentation. Thank you.